So we're going to talk a little bit more about transformations. Now, if you think of the word transform, it's like the Transformers where it's changing from like the car into the alien, or it's moving something from one spot to another. So it is transforming a shape into another shape. So it's either a congruent or a similar shape. The transformations we're going to talk about today keep the shape exactly the same. So it's going to keep it a congruent shape, which means exactly the same. So the three different types of transformations are translation, reflection, rotation. Translation is where it just slides the shape, and you can remember that because translate has an SL, so it slides. Translate also can mean going from like one thing to another. So you can translate from English to Spanish, from Spanish to English. It's just moving to different. I have words. It's moving it to different languages. Oh my goodness. So reflection is our mirror. So you see your reflection in the mirror. So if my um that's my right hand. If my right hand goes up, it looks like your left hand in the mirror. So that's a reflection. Rotation is where it rotates, it turns. So we have translation, reflection, rotation. Now we're going to take a look at the homework for 612 for CPM. So um, for your first assignment, you were taking a key and you were making the key fit into the lock, and then you're like, congrats, it worked. On the side, it was identifying and labeling all those transformations. So today you're going to take a look at, well, where does it land? So you're going to think about it. It's going to be more conceptual rather than pencil and paper. So it says Felicia found a copy of a puzzle like the one in problem 6-1, so in our last lesson, but the lock is missing. So basically, she has the key, but she doesn't have the gray key. All she has are the starting points and the moves to unlock the block. This time, her key is shaped like a triangle, so instead of the key, you just see the triangle. So it says the points are at -5, 0. So this is my coordinate grid. My x and my y. This is where my x's are positive, this is where my x's are negative. This is where my y's are positive, this is where my y's are negative. So if it's at -5, 0, -5 is my x and 0 is my y. So 1, 2, 3, 4, 5 is my A. So then it says -5, 0, -5, 3. So -5 is on the negative in the x's, 3 means positive in the y. So -5, 1, 2, 3. Here is B. And then C is at -1, 0. So -1 on the x, 0 on the y, and here is my C. So this is your triangle. It says translate. So translate means I'm going to slide. So I'm just going to 4 units to the right and 2 units up. So this is my left, this is my right. So I'm going 4 units right and 2 units up. That means every single dot moves 4 and 2, 4 and 2, 4 and 2. So 1, 2, 3, 4, 1, 2. Here is my new A. We're going to call that A prime. So like Optimus Prime, he gets the prime after he transforms. Haha. C, 4, and then 2. So 1, 2, 3, 4, 1, 2, C prime. B also moves the same way. 1, 2, 3, 4, 1, 2. B prime. Now you can move it in accordance to, like, if you move A first, B is 3. Excuse me. 3 blocks up. So you can move A and go B is 3 blocks up. C is that many 4 blocks over. Or you can move every single dot individually. Lots and lots of different ways to do the math. So that's my first transformation. It is a translation, it's a slide. Then it says reflect across the x axis. Well, here's my x-axis. So I need to make it look like a mirror image. So basically, if I were to like fold this, remember like in like elementary school when they were talking about things being like a butterfly. What's that called? The line of symmetry. So if I were to fold this, this has to match whatever's on this side. I just turned it. So I need to make sure it's the same distance from my line of reflection. So if this is my line of reflection, because it's x, if C prime is 2 away, I need to make sure it's 2 away in the opposite direction. And C prime prime, because we've moved it twice. So this means I've moved it once. This means I've moved it twice. Okay? So A is also 2 spaces away. So I need to make sure that it's 2 spaces in the opposite direction. And last but not least, I have B. Now I'm going to take where it's at from A. So it is 3 blocks away from A. So in the opposite direction, I need to make it 3 more blocks away. So 1, 2, 3, B prime prime. So now I see that it is a mirror image. So I went from this to this to this. So I can identify that. Since I don't have different colors, I'm just going to add on each time I switch the triangle. Okay, so now it says rotate 90 degrees counterclockwise about the point 3, -2. So that is your fours. In 8th grade, mostly you flip around the origin, which is 0, 0. But in this lesson specifically, it has you rotating around a certain point. So now counterclockwise, a clock goes tick, 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 tick. So we want to go counterclockwise. So we're going to go this way. Okay? So if we're going this way in our rotation, we're going 90 degrees. So instead of being like this, boop, it goes 90. So 90, 180, 270, 360, okay? So what works really good is if you have tracing paper. Now I'm actually going to go, nope, I'm going to use this Easter bag. So you don't need something that's completely transparent. I'm going to use something basically transparent. You can use cookie paper, like on baking sheet paper, you can use that. Just something that's kind of see-through. If you want to like hook your paper up to your window so you can like see through it, you can do that too. But just you need something that you can draw on and move and then like look underneath and trace it. So I'm moving it around the point 3, -2. So I have to find where 3, -2 is. I don't have my other color here. Okay, so 3 is a positive, 3, -2 here. So I'm rotating it on C prime prime. So now I'm going to get my paper that just fell. And the first thing I'm going to do is I'm going to trace my triangle over my paper. So that is my triangle. And I have C, B, A. It's exactly the same triangle as what I have on my on our board. So now I'm rotating it 90 degrees counterclockwise. So I'm going to put this on top and I'm going to rotate it on that point. So that means it's not leaving C. C is not lifting from my paper. So counterclockwise means it's going this way. It's going against the ticking of the clock. So if it's 90 degrees, I need to make it look like a windmill. So this would be me rotating that new picture 90 degrees counterclockwise. So now since I can see the graph, I can see my picture on top, I am going to kind of trace. So I'm going to leave C there. I'm going to lift and put A right underneath A on my tracing paper and put B right underneath. So if you see those dots, they're right underneath each other on my paper. Yeah, if you, again, it doesn't matter what you use to trace. You don't need a lot for transformations. And if you're able to use this as a tool, this is all you need, okay? Um, just something you can see past and so you can make your marks. So now I have my new triangle, A prime prime prime, B prime prime prime, and C prime prime prime. So these are all of the transformations in one look. Lots and lots and lots of stuff. This is like a 4 on a test. You will not have to do all of these transformations on the same object unless you really understand them. So like that's like a again, that's like a 4. So now I want you to go back through and I want you to answer these questions. I'm not gonna bring up the board again. You guys are gonna have to remember kind of like what we talked about and then apply it. So the questions are, how many quadrants should the graph have? Basically, should it have all 4 sections or just one section? Some transformations only need one section, whereas other transformations need all 4 sections. Should the axis be scaled? So basically, should we go from 2, 4, 6, 8, or should we go 1, 2, 3, 4, 5? How many units should you use for the length of each grid square? So again, that's going by 2. So if you want to go by 2, 4, 6, 8, 10, or if you want to go by 1, 2, 3, 4, or if you want to go by 0.5, should it be scaled at different, or should it just be regular 1, 2, 3, 4? Plot triangle ABC to represent the key. So if you use Desmos, basically and here I'll do a screen share of what you can do to this, and we just did it as a group together, so you can go back, rewatch, and insert your screenshot of your own work, kind of copying mine, because we did it together. So I'm going to make another video of how to screenshot and to make points and triangles in Desmos. The last question I do want you to answer is, where does Felicia's triangle end up? I do want you to tell me those points in a coordinate pair. So what's the x number, or what's the x number, what's the y number? What, in parentheses with a comma in between, you got this. So A ends up here, B ends up here, C ends up here. And then our last question for 6-10, now compare the triangle in the first problem, so the first triangle before we even moved it, to the triangle size after we've moved it everywhere. How do the sides compare? How do the angles compare? Answer that question. So basically, are they similar? Are they congruent? What do we notice that happens after our transformations with translation, rotation, reflection? If you do have questions, please feel free to message me and we will get it figured out. Okay. Bye.